அப்படி சொல்லுது. Okay, hello students. Good afternoon. Okay. Today we are going to see P block elements, one of the important chapter in inorganic chemistry, 12th standard portions. Okay. This is a new lessons to you, but only we have properties. Properties and all is very, very important. Okay. So we are doing every day one chapter. Sometimes if you have time means we are doing 2 chapter also. Okay. In our academy, we are doing every day 7 questions in 7 questions we are giving. The next day we are giving problem. Okay, it's very useful to you. So only limited students are there. So if you are interested, please come and join. And somebody is watching the video. We are getting more subscribers. So if you are interested, you can subscribe our channel. Okay. So if you are interested, you can able to join crash course. We have crash courses are going on. We have one-to-one coaching is going on. So it will be benefit to you. Okay, right. Now, in this class, we are going to study about P block elements. So P block elements means it is a periodic chart. The periodic chart. 13th through 18th group only who is occupying P block elements. 13th to 18th group. Understood? Okay. Why it is called P block elements means the elements having the last electron present in what? P orbital. When you write electronic configuration, the elements having the last electron present in P orbital. That's why it's called what? P block elements. For example, if you take boron atomic number 5. So 1s2, 2s2, 2p1. The last electron present in which orbital? P orbital. That's why it's called what? P block elements. Simply you can say. It occupies 13th to 18th group. It has one general electronic configuration. That's what? NS2, NP 1 to 6. Okay, it's a general electronic configuration for P block elements. Particularly each and every group we have configuration will be there. Okay, that also important. Suppose here it ends with boron family, carbon family, nitrogen family, oxygen family. Otherwise it's called chalcogens. This is called halogen. This is called inert gases. You know that. Okay, right. So here if you take boron ends with what? 2s2, 2p1. So this family also ends with what? ns2, np1. Understood? Are you following? This is what? ns2, np2. This is what? ns2, np3. This is also very important. They'll ask in. Okay. They'll ask. This ns2, np4, ns2, np5, ns2, np. Then only we are saying all are ns2, no? ns2. It starts from np1 to np6. Then only general electron configuration of P block elements is what? ns2, np1 to 6. Okay. Now 13th and 14th group we have. This is the syllabus in 11th standard. Now we are going to study about only 15, 16, 17, 18. This group elements only we are going to study in this. Okay, in this chapter. Okay. So now if you take 15th group, you know that. What are the elements in 15th group? I have given clearly: nitrogen, phosphorus, arsenic, antimony, bismuth. These are the elements in this group elements properties only we are going to study. Okay, understood? Right. Before that, you must know. Suppose here, if you start from here it consists of metal as well as non-metal as well as metalloid. Suppose if you start from here, suppose here if you do like this, if you do one zigzag line, if I do one zigzag line, we are getting. Are you following? Suppose if you do one zigzag line, that is boron, it goes on silicon, then germanium, arsenic, antimony, tellurium. This is called polonium, astatine. So if you put one zigzag line, okay, the left hand side is called what? Left hand side is called it is called metal, correct or not? Right hand side is called what? You can say what? Non-metal. The metal on the zigzag line, no? That's called metallite. It's called, if I put one line, I put like this. Okay. Understood? If I put one zigzag line, okay. Right. This is nothing but silicon. Okay, silicon, this is called germanium. Understood? That. This is called antimony. Antimony. This is called polonium. Okay. If I put one zigzag line, left hand side metal and right hand side non-metal on the zigzag line, this is called metalloid. Okay, this is called metalloid. This element is called metalloid. Okay, right. So now we are going to study about the 15th group elements. What are the elements in 15th group? Tell me. Nitrogen, phosphorus, arsenic, antimony, bismuth. Correct or no? Okay. So here, that suppose your sources means where it is present means it is present in atmosphere, nitrogen, 78% by volume. That. Apart from that, it is present in salt also, KNO3. This also is given in textbook. KNO3, potassium nitrate, sodium nitrate. Okay, in the salt it is present, nitrogen is present. So the sources. Okay, this is called Chile saltpeter, Indian saltpeter. One nickname is there. Then phosphorus, it is in the form of it's also in phospholipids in egg as well as milk. Then this all is in the form of what? Sulfide ore. Sulfide ore, it is there. Okay, understood? Right. Then, suppose here, now we are going to study about only the general properties of 15th group elements. Okay, what is that? Electronic configuration NS2, NP3. Understood? Right. Okay. Then, general properties means, generally you can say, suppose when you go down the group, what happens? Atomic size. When you go down the group, atomic size increases. Are you following? So general properties means when you go down the group, atomic size or atomic radius increases. Understood? Other properties are decreases. Other properties mean electronegatividity, electron affinity, then ionization energy. These are all what? Decreases. This is general one. For any group, we can write like this. Understood? Atomic size increases, but electronegativity, electron affinity, ionization energy always decreases when you go down the group. Okay? Right. Understood? Okay. Understood? Right. Next one. See, textbook here they are given. See, now we are going to compare the, what are the elements in this family. So nitrogen and phosphorus are what character? Nitrogen and phosphorus only what character? These are all. It is present that side, no. Non-metal, correct or not? Non-metal, correct or not? Then this arsenic, arsenic and antimony is what? Only metalloid. Correct or not? Arsenic, are you following? Then arsenic, it's called what? Metalloid. Understood? This only is the metal. So when you go down the group, metallic character increases. Are you following? Non-metal, then metalloid, then metal. So when you go down the group, metallic character increases. This is all Understood? So generally, these are general properties. Atomic radius, electron affinity, electronegativity, these are all general properties. Okay, understood? Okay. Now, we are going to study about some peculiar characters about nitrogen. Okay, suppose that's one we are seeing, it's called anomalous nature of nitrogen. Nothing but the meaning is nothing but it has nitrogen having some peculiar characters. When compared to nitrogen compared to other elements in the same family, it has some peculiar character. Okay, so peculiar character means suppose I make it a difference. Some important points I'll give. Phosphorus. We are comparing nitrogen and other elements in the same family. Can you be understood? Arsenic, correct or not? Antimony, bismuth. this point, when compared to other elements, this is what? Small size, following, small size, high ionization energy, high electronegativity, high electron affinity. This point, okay, others are low. I am going to write these points only. You just imagine, other will be just quite opposite. Okay. Then, see, it has maximum covalence is 4 only, they are saying. Okay. So, nitrogen having maximum covalency. Covalence is, sorry, not only 4. Okay, not only 4. It does not have any valency 5, because, the only one reason they are saying it has no, because of what? Due to absence of what? D orbital. It has no D orbital, no? When you write electronic configuration, no D orbital. But here having the third cell will come. But here only 2 cells are there. There will be no D orbital. So no D orbital. That's why it has maximum valency 4 only. But it will be more than 4. Understood? This point important. Then, what's the bond order? Then, what's the bond? It's a diatomic, It's not diatomic. Correct or not? N2. But this will be sometimes polyatomic. Phosphorus we can say what? P4 like that. Okay. Then next one is, bond, the bond order. What is the bond order here? Bond order means what's the formula? You studied. Bond order is equal to what? 1/2 NB minus N of A, we studied 11th standard. Number of electrons in bonding orbital minus number of electrons in antibonding molecular orbital. Here, just write 3 only. Then only we put what? Nitrogen triple bond N. Correct or not? Bond order 3 means in between 2 nitrogen, the bond will be what? 3. Understood? Right. Then only it is what? But the bond is 3 bond, no. Then it is more stable. Then only we can say nitrogen is what? Inert. Correct or not? Okay? Not react. It is present in the atmosphere, but not react, no, because of inert character. Inert. Okay, because of bond. 3 bond is there. When compared, but oxygen what? But oxygen is what? O double bond O. When compared to this and this, O is more reactive. Oxygen is more reactive. Are you following? The bond decreases, reactivity will be increases. If you take hydrogen, only single bond, double bond, triple bond, no. Okay, so more bond, no. So more force of attraction. It will not react. Then only we can say inert. Okay. Then next one is, it forms P-pi bond. That's very important. Others can form D-pi bond. The overlapping takes place. Yeah, the outermost orbital, two p orbitals will overlap. In this nitrogen one p orbital, in this nitrogen one p orbital overlap to form pi bond. Then it is called P-pi bond. Okay. Right. Then it is what? It is inert due to what? Sometimes they will ask, nitrogen is inert due to bond enthalpy is very high. Just write here itself. Bond enthalpy. Bond enthalpy means the energy required to break the bond. Correct or not? It will be very high. Okay. So these are some important points. Just note down. Okay. Maximum covalency 4 only. Nitrogen bond order 3. It forms only P-pi bond. Okay. Understood? Then only it has some peculiar character when compared to that. Following? Nitrogen only diatomic, others may be polyatomic. Okay. Right. No allotropes. This is also very important. It has no allotropes at all. No allotropes. Allotropes means what? No allotropes. What is allotropes? We have red phosphorus, white phosphorus. Both are phosphorus, isn't it? Allotropes means, appearance will be different, but existing same element. Okay, white phosphorus, red phosphorus, rhombic sulfur, monoclinic sulfur, isn't it? Different, no. If you take, best one, Allotropes of carbon, diamond, graphite, fullerene, all are made up of what? Carbon, but appearance will be different. That's called, we can say what? Allotropes. But no allotropes for, here what? For nitrogen. Okay, understood? But it has, just right, but it has only, it has isotopes, N14, N15, isotopes, just right, isotopes. Okay, right. These are the important points about that. Okay, first, each and every group we are going to study about general properties. Then we have some compounds will be there inside. That also we should study. Okay, right. Written all this. Okay. What's the bond order of nitrogen? 3. Okay. When you write, you study that time. Now itself study some important points. Okay. Okay. Next one. Some chemical properties, general properties. Okay. General properties is very important. Okay. See that. What are the important properties? Means all these elements, all these elements is going to react with hydrogen. Okay. First one, reacts with, right, fast. Reacts with, whenever it reacts with hydrogen, it forms what? EX3 type. What is EX3 type? Not EX. EH3 type. What is the meaning for this? Nitrogen, here E means any element. In this place we put, any element means the element in nitrogen family. Understood? NH3, correct or not? N, not B, BH3. Tell me. AS, okay, it goes on. Okay, so I'll write in this way. Tell me. PH3, ASH3, then SB, S3, then BAH3. Understood? Right. So here, you know that order. Here they'll ask some questions based on which one is more stable, which one is strong reducing agent, like that. Okay. First one is stability trend. You put one by one. The ammonia is more stable because of small size. That's all. Okay. Stability trend means here more stability is like this. AS. Okay, right. Then another one is, reducing trend. Reducing trend means here among this which one is metal here? Who is the metal here? Bismuth is metal. Metals are more more reducing agent when compared to non-metal. Understood? Okay. So this is more means what? This is more, no, just quite opposite. Correct or not? Metals are more or strong reducing agent. Understood? See, you just write. So this will be least, isn't it? Right. PH3, ASS3. Understood? Then SBH3. Then what? BiH3. Understood? Right. Next one. Right. Reducing agent, no? Okay. Next one is basic trend. Which one is more basic? Which is more basic means basic always due to what? Due to lone pair of electron. Isn't it? Due to lone pair of electron. Are you following? So everyone having lone pair, no? Correct or not? Everyone having lone pair. One pair will be there. Understood? Everyone having lone pair of electron. So from this only we can decide which one is more basic. Understood? Okay. Everyone having lone pair of electron. Isn't it? I am saying this is the more basic, because this ammonia only can able to give the lone pair of electrons to someone. But when it comes to phosphorus arsenic, this lone pair of electrons are taken by the d orbital. They are saying here empty d orbitals, empty d orbital, here also empty d orbital. Okay, here no d orbital, no. Okay, so the in ammonia molecule only it can able, it is a more basic. So because of it's giving a pair of electrons to someone. Okay, understood? Then only it's called basic. Understood? Any species giving electron, no, that's called more basic. Any species can accept electron is called acidic. Understood? Among this, who is more basic means this is ammonia is more basic. Okay. These are all less basic, no? Less basic due to what? Less basic due to lone pair of electrons used by d orbital. Are you following? Due to lone pair of electron consumed by the empty d orbital. You put like that, empty or vacant d orbital. Understood? Okay, right. You following? Most of the information I am giving without your book, you can study all this from my notes itself, I think. Done. Next one, fourth one, reducing property, I already told you, there is, hydrogen bonding trend. Hydrogen bonding also basic, more or less same. This only can make, small size only can make more bond when compared to that. So, but that same trend you can follow. So, NH3 is, right, you're right, okay, same. That's all. Simply they'll ask, here, simply they'll ask, which is more stable hydride? So this trend, just keep in mind, okay? Understood? Finished? Second property, this reacts with hydrogen, no, reacts with oxygen. Right, here it forms E2O3, E2O5. Right fast. It forms the two kinds of oxide, correct or not? It forms two kinds of oxide. What are the oxides? E2O3 and E2O5. Because valency 2 and 3, because 2 and 3, balance only used. 2 is there, sometimes 3 is there. Not 2 and 3. See, 3 and 5. See, sometimes, because this 2 will not use, because due to inert pair effect. S orbital maximum how many electron? 2 electron, no. This 2 electron will not participate easily due to inert pair effect. So, 3 and 5, that's a valency, correct. 3, sometimes 3, this is what valency? Element 3, no. So valency 3 is used. Element 5, correct? 5 is used. Understood? Right. So you know that what are the, instead of element you put, N2O3, correct? P2O3, it goes on. Okay. Likewise what? Bi2O3. See, this is non-metal, no? Just remember, always non-metal can form acidic, metal can form basic, just remember. So non-metal means these are all what? Acidic, these are all what? Acidic oxide. In between, no? Overall in between AS2O3 and Sb2O3. Understood? These are all what? This is, confirmed. This is a metal only, no? Metal. So metal only means it's called what? What oxide? It forms only basic oxide. Are you following? So this will form in between, no? Amphoteric. Okay, right? Amphoteric, right? Are you following? Some very simple question they will ask. We have so many 5 options is there, but in your examination only we have only 4 options. Yeah. Who is metallic oxide? Only who is basic oxide? Only metal only can form basic oxide. Non-metal can form what? Acetic oxide. Just keep in mind. Understood? Then when you compare this and this, suppose this also what? This also, both are non-metal, no? Okay, both are non-metal, but who is more acidic? Who is more acidic means the valency, who is more oxidation state? N2O3 and N2O5 means, okay, you just write here N2O3 and N2O5 means this is the more acidic, they are saying. Simply remember, just write like this: more oxidation state, more will be what? More acidic. You write like this: more acidic, then more covalent character. Write fast. Very important. Following. The general, see, when compared to this is more acidic, more oxidation state is used. No, oxidation valency done nearly. Just remember like this: the oxidation state, more oxidation state is used, more acidic. More acidic means it's considered more covalent character. Okay, most of many places we can get this one. Understood? So simply we can say this is what? More acidic. Understood? Right. This one you know down. Next one. React with what? Halides. React with halides. Halide. Write fast. Third property. React with halides. Understood? Please do. Okay. All the elements react with hydrogen, oxygen, then halogens. Okay, right. So this is a general formula. Okay, P2O3 and okay. Here, what's the formula? What's the formula used? EX. That general formula you just keep in mind. X means it's a halogens valency always 1. If you use 3 here, I told you 3 and 5 is the valency. So it will be what? EX3 type, then EX5 type. Are you following? X may be any halogens. Okay. A may be the elements in 15th group. Are you following? NCl3, PCl3, ASCl3, SbCl3, BiCl3. Understood? Right. Here NCl5, PCl5, ASCl5, cut or not? Okay, right. Understood? Here some exception case will be there. See, they are saying this will not form. This also will not form. The nodal. Okay. I told you, the nitrogen having maximum covalence is what? 4 only. So how it will form? 5. Okay. Due to it will not form. Due to absence of what? D orbital. Understood? So it's not formed. Correct or not? B? This also will not form. Here due to inert pair effect. Inert pair effect inert not 2 electron in SR will not participate. 2 electron. Okay, some case, so this is one exceptional case. Okay, due to inert pair effect, increases when you go down the group, increases. Okay, inert pair, this 2 electron will not participate. Okay, due to inert pair, that the reason just go through. So maybe it forms PiCl3 only, maybe not PiCl5 will not form. Okay. Here also some points are there. You go through here. Some properties is there here. Okay. Just next one. That's all. These are the general properties about which family, nitrogen family. Okay. Now we are going to study about some compounds. Okay. I think the nitrogen compounds, phosphorus compounds only we have. Okay. So generally I'm going to give an idea. Okay. What are the compounds are there? How to prepare? Okay. You just go through your textbook also. Okay. Right. Okay. Right. See here. Now we are going to study about compounds. Okay. In nitrogen based compound. Nitrogen based compounds, only nitrogen we are going to study. Next one is we are going to study about what? Ammonia. Next one we are going to study about what? Nitric acid. Okay. Then phosphorus based compound we are going to study about PH3. Then PCl3. Then PCl5. These are all we are going to study. These are all phosphorus based compound. Correct or not? Okay. First you write like that. I'll give some idea how to prepare this and all. Okay, just go through the textbook also. Okay, these are the compounds in nitrogen as well as phosphorus. Okay. Apart from that, we have oxo acids of phosphorus. Okay, that I'll give later. Okay, so here, okay, so each and every one we should know the preparation. Okay, nitrogen we know it is present in atmosphere. How to prepare means if prepare, so many methods are given. Study only one method of preparation. See here how to prepare means barium azide. One compound is there. It's called barium N3 na azide. Okay, barium azide. If we heat means what happened? What happened? Barium will be separated, nitrogen also. After you can balance the equation. Okay, or if you use ammonium dichromate, NH4 twice, Cr2O7. When you heat means that time also we are getting what? Nitrogen gas plus Cr2O3 plus what? H2 will be obtained. Understood? Okay, so these are method to prepare. Okay. You following? Okay. So I'll give an idea. If I suppose five methods, I'll give 2 or 3 methods. Okay. Other method you just go through a textbook. Okay. Right. Next one. Okay. Then come to ammonia. Ammonia is here. Okay. Okay. See that? So these are the compounds, no? Nitrogen, ammonia, then nitric acid. Okay. So we are going to study about preparations, no? We need some space. Okay, I'll write it here. Okay, nitric acid. Understood? Simple. It is prepared by, it is what is this? Ammonia. You know that. This is called what? What is this? Nitric acid. Understood? Okay, right. It is studied. What is this? It is how will you prepare this one? By Haber's process. It is prepared by what? Oswald's process. Understood? Okay. Understood? Ammonia, no. What are the things are needed? N2 plus H2. Correct or not? Okay. It's an equilibrium process. Then only we have to maintain certain temperature, certain pressure, certain catalyst. Then only we can get the product. Otherwise, it will come back. Okay. So certain temperature means nearly 700 Kelvin, 200 atmosphere pressure. Okay. Then iron oxide is a catalyst. This all just go through. Okay. What are the necessary conditions they will ask mostly? Okay. Understood? Next. Okay. Then the preparation of ammonia. Then about ammonia, you know something about that. What is this? Ammonia, structure is what? It is one lone pair, no? Lone pair, no. So ammonia, we can say it's called what? You write one by one down. Okay. Ammonia is a what you can say? Lewis base. Okay. What is the structure? Can you give like this structure? 3 bond pair, 1 lone pair. Correct or not? 3 bond pair, 1 lone pair. And you have 4. That's what it's called. What's the hybridization of this one? sp3 hybridization. Understood? Shape is what? Pyramidal. These are all just note down. Okay. Okay. Then nitric acid. Other preparation is then uses and all you just prepare yourself. Ammonia means mostly to prepare any fertilizer. Okay. Diammonium phosphate, urea, this and all we can able to prepare by only ammonia. Understood? Then nitric acid formula is what? HNO3. Yes, nitrogen compounds, no? Okay. It is prepared by Oswald process. Okay, it has also, we have steps will be there. You just write ammonia is oxidized to get what? NO plus, H2O. This NO again is oxidized to get NO2. Again this NO2, reacts with, water molecule, we get, HNO3. Then plus what? NO is obtained. These are the steps. Okay. Here platinum is a catalyst we can use. Okay. So I'll just go through. You have 3 steps to get, not only 1 step. Ammonia is oxidized to get NO. The balance equation, don't worry about the balance equation. NO plus O2, NO2, then NO2 plus H2O, we get HNO3. Okay. Okay, right. The most important one is for nitric acid. I write it here. For nitric acid, nitric acid is a, nitric acid is a strong oxidizing agent. This is very important. Okay, strong oxidizing agent. Oxidizing agent. Understood? Nitric acid is a strong oxidizing agent. Understood? What is the meaning for that? Simply I am saying it oxidizes C to CO2. It means what? It means what? This is HNO3. Okay. Oxidizes carbon to carbon dioxide, sulfur to sulfuric acid, like that. Phosphorus to phosphoric acid. So, okay. Then this will undergo reduced. It oxidizes other one, no. It undergo reduced to form what? NO, like this. If you have sulfur, If you have sulfur means what? It becomes what? Sulfuric acid plus the NO2 plus O2 is not common. Understood? Right. It's an oxygen agent. This is an example. Okay. Actually, in a textbook, sulfur is a 8. It's a 8 atoms together in one molecule. S8, P4, O2, N2. These are all diatomic. These are all 8 atoms together in one molecule. Okay. Then it is a planar structure. HNO3 is just right. Last 2 years back, this question they asked. HNO3 is a planar molecule in gaseous state. Planar molecule in gaseous state. That's right. It's all important. Planar molecule means all the nitrogen, hydrogen, oxygen are present in the same plane. Okay. That's why it's called planar molecule in gaseous state. But liquid state, it will be somewhat different one. Okay. So I'll just go through. Understood? Finished? Then one more very important question, that is, you study the brown ring test, no? What is brown ring test? The test for chromyl chloride test for chloride, brown ring test for nitrate, silver nitrate test for chloride. Study, no? Sodium bicarbonate test for carbonate. Yeah, lead acetate test for sulfate. Likewise, brown ring test, that's a test for nitrate. That brown ring test, if you want to do, means we are using what this acids. Okay, so here written all this. Okay. In brown ring test, you take nitrate salt, add ferrous sulfate, add constant sulfuric acid. At last you will be getting one brown ring will be formed between the junction of the layer of the solution. No, one brown, it is a okay. It's a one brown ring is formed between the between the two layers or between the solutions. Okay, or one layer will be formed. It's a brown ring layer. Okay. That this only they're asking how this layer is obtained means it's a one complex actually. Okay, that complex only they're asking the brown color layer, the brown layer due to which complex they are asking. Just one note down 5 times NO. Okay, one complex 2 plus just right. The brown layer or brown ring layer due to the formation of this complex FeH2O5 NO2 plus. Just note down. The brown layer in brown ring test due to the formation of this complex. Understood? Okay? We're following. Right, next one. Just note down whatever I am giving, just note down. FeH2O5 NO, it's very important. Okay. Okay. Okay, now we studied then nitrogen compounds, no, okay, nitrogen based compound, okay. Then you just, I'll give some important information there, not full. What are the compounds of phosphorus means? I told you PH3, PCl3 and PCl5. These are all compounds of phosphorus. Are you following? Okay. Then this is called, is the name of the compound is called phosphine. Phosphine. This is called phosphate trichloride, phosphorus pentachloride. This is all yeah. Right. Here, PH3 preparation. I will give only one method of preparations. Here it is prepared from red phosphorus. Sorry, it is prepared from white phosphorus. P4 means called white phosphorus. We have two kinds of phosphorus. It is always prepared from white phosphorus plus NaOH plus H2O. Okay, it's a familiar equation. Then only I am giving this one, NaH2PO2. Okay, right. Phosphine is a, we can say what we can say. Phosphine is a hydride of dash is a hydride of phosphorus. Phosphine is a hydride of phosphorus. These are all chlorides of phosphorus, correct? Chlorides of phosphorus. Phosphine is a hydride of phosphorus. Understood? Right. Right fast. One preparation I have given. Okay. Then properties means, some important properties, it's a rotten fishy odor. Rotten fishy odor. Okay, right. Then very important one is, home signal. I heard about this word, home signal. Home signal means what? What is home signal? Its compounds are useful to signal for the nearby ship. In those days, there is no communication facilities. So its compounds are making fire as well as white fumes. Then only it's a signal for the nearby ship. Its compounds nothing but what are the compounds means? Calcium carbide and calcium phosphide. Just remember. Okay. If you put this in water, what happens? This makes, it forms C2H2 as well as PH3 will be formed. Okay. Understood? Just note down. Fire due to acetylene, PH3 due to smoke. Okay, due to the formation of, smoke will be formed as well as fire will be formed. Understood? Smoke also will be formed as well as fire also will be formed due to the formation of. So if you have any problem in the ship, they usually, if you have once, we are going. Okay, whenever they are going to sea, they are using these compounds, calcium carbide and calcium phosphide. If any problem with the ship, they put it into water. Whenever these two compounds are reacted together with water to form fire as well as smoke, that will give immediately some fumes will be formed, or fire also will be formed as well as smoke will be formed. That's it. They are saying, okay, then only it's a signal for the nearby ship. Then only we can say these two compounds is called what? Home signal. Okay. This also keep in mind. Just this all, don't worry about that. Yeah, calcium carbide and calcium phosphide. It's called home signal. Okay, right. Then one more information. It is a strong reducing agent. Strong reducing agent. Right. I am giving only one more information. It will take 3 hours at least for complete one lesson. Yeah, isn't it? At least few information if I want to give means it will take 3 hours for completing this lesson. At least 3 hours. If I want to give more information means it will give more time, I think. So mostly I covered. Okay. So some of the any uses and all, just you go through your textbook. Okay. So mostly I covered. Then this is all preparation simple one. Phosphorus plus chlorine, phosphorus plus trichloride. Okay, preparation simple one. one of the important properties there. Properties means, reacts with water. That's very important. PCl3 plus water molecule to get H3PO3 is obtained. H3PO3 plus, HCl. See, just compare and study. See, PCl5 plus water, we get H3PO4. That's the only difference. H3PO3 is called phosphorus acid. This is called phosphoric acid. That's the difference. Okay. This one study. Structure means, what is the structure? Trigonal bipyramidal. Just shape is not trigonal bipyramidal. Correct or not? Wait. This is only correct one. How to write this one? This is the correct one. P in the middle. Here chlorine. Correct or not? Cl. Trigonal bipyramidal. This only shape is what? Trigonal bipyramidal. Understood? But this is only pyramidal. That's all. Pyramidal shape. Okay. That's all. Write fast. Understood? Then understood? PH3, PCl3, PCl5, these are all compounds of phosphorus. Okay. Right. Next one is last part of this group. Oxo acids of just write oxo acids of phosphorus. Oxo acids of phosphorus. Okay. Oxo acids means, oxo acids of what? Overall oxo acids means, I'll give some important thing, oxo acid means some acidic character, OH will be there. To the phosphorus, OH will be there. Okay. So when you draw the structure, we are getting OH. So it's called oxo acids of phosphorus. What are all means? H3PO2, H3PO3, understood? Then H3PO4 goes on. Okay. Some important only just write. H3PO4, H4P2O7. Okay, this is called hypophosphorus acid. Hypophosphorus acid. This is called phosphoric acid. This is called, only phosphorus. This only phosphorus only. Phosphorus acid. This is called hypophosphorus. No, small difference will be there. This is called phosphoric acid. Understood? This is called, pyrophosphoric acid. Pyrophosphoric acid. Understood? Okay. Okay. Important one is you put the heading basicity. Okay, basicity. Basicity, how to find out means from the structure we can able to find out basicity. Okay. Structure how to draw this one. See here, phosphorus valency 5. So here 1 OH, compulsory OH will be there. Then it's called oxo acids. Understood? OH. The remaining H only, Here, cut or not? Here double bond O. Okay, right? Basicity means here one OH is present means what? Basicity is what? 1. Number of OH, understood? Basicity depends upon number of OH group. Then here one oxygen increases, no? Yeah, it's a 2 OH, 3 OH like that. Understood? Are you following? Okay, then here OH. Here also OH. Tell me. Here OH, here also OH, here single bond, here double bond O. So 2, correct or not? Best it is 2. Okay. Likewise here best it is 3. Here what? 4. Right. Quick. This one I put, you make it, you remember like this, pop, P-O-P, pop, because 2 positives, no? Pop. I told you best is what? 4. So you put what? 4 OH. Understood? 4 times OH. Understood? Here, as usual, double bond O. Cut or not? 7 oxygen will be coming or not? So best is what? 4. Understood? Reducing agent trend. Reducing agent trend means, see, here, the hydrogen is directly bonded to phosphorus. Hydrogen is directly bonded to 2 hydrogen, no? Here 1 hydrogen, here nothing. So, who is more means what? Who is more, strong reducing trend means what? H3, PO2, then H3, P3, it goes down. Okay. But apart from this, best one is what? PH3, correct? Just note down. PH3, 3 hydrogen is directly bonded. Understood? So this is the strong reducing agent. Okay. Hydrogen should be bonded directly. Understood? Next. Okay. It's all important. Note down. Important. Okay. Okay. That's all. We completed 15th group. It takes how many time? 1 hour, no? For completing one group, it takes what? 1 hour. Okay. So the last group, very simple one. We have only 1 pages or 2 pages are there in your textbook. Okay. The first is 15, 16 only. 15, 16, 17 only somewhat hard. Okay. 16th group. So say the important things. Just like you have to prepare. Okay. So general properties of this group. Then some commons are there. But here only 2 commons, 6 commons, nearly commons we studied. But here and all 2 or 3 commons. Okay. What are the elements in this family? You know that. Yeah. Oxygen, sulfur, selenium, tellurium, and polonium. Among this is what? Some difference will be there. Radioactive. Its half-life period is what? 13.8 years. This also note down. Among these are all what? Non-metal. Correct or not? Non-metal. Selenium. Up to selenium is also non-metal. Yeah. Up to selenium is also non-metal. This is what? Metalloid. Correct or not? Huh? Metalloid as well as radioactive elements. Okay. Okay. Then it is present in atmosphere. It's 20% by volume, 46.1% by. It's not like go through. Okay. Then sulfur. How sulfur in the form of which ore? Which ore? Sulfide ore. Right? Or in the form of sulfate, no? Sulfate. Right? Sulfide ore, no? We can say anything. Zinc sulfide, yeah. Cinnabar, yeah. In the form, sulfur in the form of sulfide ore, or in the form of sulfate. Sulfate means what? Calcium sulfate, gypsum. Gypsum like, okay. It's how the sulfur means in the form of sulfur as well as sulfide ore as well as sulfate ore. Okay. Other things also present in sulfide ore. These two is important. Okay. Just note down. Then, then general properties. Usually, uh, you know, last time we studied, when compared to oxygen and other elements, oxygen is small size, high electronegativity. Yeah, these are all general properties. Okay, you study yourself. Then one more very important one is oxygen only diatomic. These are all, 8 polyatomic. Okay, so boiling point suddenly increases due to what? In one molecule, 2 atoms are there. In one molecule, how many atoms are there? 8 atoms. So here is high boiling point due to polyatomic. Okay, just note down. High boiling point, just write. Boiling point. It has more. Okay, right. It has more due to right. Boiling point. Some of the important information just note down. It's enough. Finished? Okay. Then some chemical properties means then apart from that you just oxidation state, just note down. What are the oxidation state means? I'm saying -2, -1, +2. -2 means what? H2O. -1 means what? H2O2. Peroxide. In case of peroxide, it has what? Always -1. +2 is also there. Whenever fluorine is a highly electronegative element, correct or not? Electronegative trend. Okay. Next to fluorine, who is there? Oxygen. So whenever both are electronegative character, but whenever this oxygen linked, combined with fluorine, that time only it will be what? +2 oxidation state. Okay. Whenever oxygen is also more electronegativity, this is also more electronegativity. Whenever these elements commence with highly electronegative elements, that time only it will be what? +2. Correct? So how to find out? See X. One fluorine -1, so -2 is equal to 0, X equal to +2. Okay, right. Okay. Note down. These are all only what? For whose oxygen state? Only oxygen state only. Sometimes -2. In case of peroxide, -1. Whenever it reacts with, it combines with highly electronegative elements, that time it will be +2. Okay, right. Next. Okay, right. Next one. Okay. Then some chemical properties, just put chemical properties. Suppose here it also reacts with hydrogen. First one reacts with hydrogen. So what? Whenever it reacts with hydrogen, what happened? H2E, correct? H2E na? Its valence is always 2 da. So what? H2O, correct? H2S, understood? H2SC, H2TE, last element, leave it. It's radioactive elements, leave it. Okay. So here, these are the compounds will be formed whenever it reacts with hydrogen, no? Right. Stability, as usual, small will be what? More, as usual. Acidic trend, note down. Acidic means what? Readily lose hydrogen, no? Readily giving hydrogen. It's called acidic. but this will not give. It's due to highly electronegativity character, it holds the hydrogen, so the trend will be quite opposite. Okay, who is more acidic na? This will be the more acidic, correct? H2D, understood? Right. This will only go through, it's enough. Done. Finished. Next one, reacts with halogen. Reacts with halogen means here it forms halogen means valency 1, it's valency 1, it's valency 2, so on. Here, three different kind of halogens will be formed. See that EX2, EX4, EX5, EX6. Just remember. Okay, different kind of halogens will be formed. One example, just go through. It's enough. Especially, S of 6. This is called SF4. This is called SCl2. There one exception case will be there. Selenium does not form dihalides. Just note down. This is called hybridization sp3d2. This is called sp3d. This is called sp3. Note down. Hybridization. sp3d2 na, what's the shape? Octahedral, no? Octahedral. This one is somewhat different one. SF6, SF4. See, SF4 you studied in 11th standard. Sulfur is attached to 4 fluorine, no? 4 fluorine, no? 4 bond pair. But sulfur 16 liya, 2, 8, 6. 4 electrons are useful to make a bond. So 4 BP, 4 bond pair is there. Remaining 1 pair is there, 1 pair is called 1 lone pair. So totally we have 5. 5 means this structure only we have to put. What structure means? Trigonal bipyramidal structure. Okay. Then, okay. One lone pair, no. That one lone pair I put it here. One lone pair I put it here. Other place? 1, 2, 3, 4. Correct? We cannot say trigonal bipyramidal. Here also one atom is present. Are you following? Here also one atom is present. It's called trigonal bipyramidal. Understood? Here also an atom is present. But here one lone pair is present. That's why it's called what? Seesaw. Very important. Choose the best answer. Seesaw shape. Okay. Seesaw, understood? They won't give only one question in your NEET examination. They will give match the following like this. Okay. SF4, A in D answer. You have to match. Okay. So that kind of questions we can expect in this. Suppose SF6 octahedral. Okay. Sometimes they won't give in middle column also SF6 hybridization shape. So which one is correctly matched, you have to find out. For one answer, if you want to attend, you have to come across 3 or 4 answers. So all the information, then I am giving all this. Okay. This is actually sp3 na tetrahedral, but a lone pair is also there, but it's not a tetrahedral. It's called bent shape. All this, 4 atoms are around sulfur. It's called tetrahedral, but no 4 atoms. No, maybe lone pair will be. It's called bent shape. Right. Fast. It's enough. This is all you go through. Finished? All this. Who is more acidic? This type of question will be there. Yeah, 4 options. Yeah. Who is more acidic? How many options we have? 4 options. Clearly it's given. This is more acidic. Okay. Because acidic means readily giving H plus ion, but it will not give because of it hold, because of highly electronegative character. Okay, it holds the hydrogen with itself, so hydrogen will not eliminate. Okay, this is more acidic. Okay, so you just prepare like this. Okay, very tough, but some concept I am saying no, you just keep in mind, you can able to understand. Okay, I think based upon shape, based upon hybridization, you will be getting the question like that. Okay, based upon trend, all the trend study. If you study the trend like questions, your trend is going to modify. You also become a doctor, no? If you want to become your trend is going to change, no? So that study all the trends in P block elements thoroughly. Okay, right. Work hard, what we do. Only few days are there. Okay. Then, as usual, I told you compounds. Okay, what are the compounds means? Just I give an idea. What are the compounds in 16th group means? First O2 is given, not so important. I start from O3, ozone, SO2, sulfuric acid. This 4 is very important. This 3 is very important. Okay. Ozone means O3, Leah. Understood? Right. You know that it is a earth protecting umbrella. No, it prevents the UV rays directly to the, it prevents UV rays. Otherwise the UV rays directly come to the earth, it will cause, studied skin cancer and all studied. Okay. So it is prepared from oxygen. Okay, oxygen is, when you pass oxygen into ozonizer tube, or when you pass oxygen into electric discharge tube, so O2 molecule breaks down into what? Nascent oxygen. That nascent oxygen means you put in bracket. That's a nascent. Nascent means newly prepared oxygen. Molecule become atom. That's all. Are you following? Okay. When you pass into electric discharge tube, then this nascent oxygen plus any molecule to form what? O3. Molecule plus atom, again molecule. Understood? Right. Then it's a very important one is this one of the important properties means it acts as a powerful oxidizing agent. That study go through. Okay, it's oxidizing agent means it converts what? It just not on. It converts lead sulfide into lead sulfate. You see the equation in your textbook. It converts lead sulfide into lead sulfate. So that it's called what? Powerful oxidizing agent. Okay. Then we are saying there is a hole in the ozone. Yeah, that is due to the 2 important gases. One is that's why we can say depletion of ozone layer. The depletion of ozone layer, okay, ozone layer due to the 2 important gases. One is called NO and freon. Freon means what? CFC. Just note down. Okay. this preparation and all is very simple. It's not, any sulfide ore is roasted, roasting we study, roasting means sulfide ore is roasted, we get what? In the book they are given iron pyrites is roasted to get what? Iron oxide as well as what? Sulfur dioxide. Just note down. Properties, if you take properties means SO2 is a strong reducing agent. Let's note down. It is a strong reducing agent. It's one of the important properties. Strong reducing agent means it reduces ferric to ferrous. Okay, suppose ferric means reduce means number degrees. No, ferric becomes what? Ferrous. Are you following? Ferric becomes ferrous. So generally it's called strong reducing agent in process of ferrous to ferric nada H plus in left hand side, H2 on right hand side. It's quite opposite. It will be like this. Then it reduces ferric to ferrous. At the same time, it will be oxidized. Okay. Study. Just note down. Correct? Understood? Two processes we study now. Ammonia, what process? Simply melodically they will ask. Ammonia prepared by ammonia. Ammonia, Haber process. Nitric acid, Oswald process. Sulfuric acid, what process? Contact process. Chlorine, Decan's process. Glauber process, nothing but preparation of HCl. So the 5 processes are there. Okay. Study the process name at least. Okay. Here the same method now. Here SO2 is formed. No, this SO2 as the basic raw material is what? Iron pyrites now. Iron what? Pyrites. 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 Is roasted. What happened? Tell me. It becomes what? SO3. Again SO3, reacts with small amount of sulfuric acid. Why adding means to remove any dust particles as well as arsenic impurities. Just remember. Then only we are getting H2S2O7. Not getting, this is called what? Oleum. Okay. Again this oleum, H2S2O7, again reacts some, it's a highly concentrated sulfuric acid. Add some water molecule, then only we are getting what? 2 times sulfuric acid. This is the way to get. Here platinum is a catalyst. Very important, note down. Understood? Right. This is the information go through. Then it's having some properties. What's the important properties means? I'm writing right here. Just note on. 2 properties are important. Nitric sulfuric acid. Okay. Sulfuric acid acts as a very good dehydrating agent. Correct or not? Okay, to remove water molecule. Suppose your best one is, if you take sucrose, C12H22O11, if you add what sulfuric acid, what happened? This will be removed. H and O will be gone. Who is there? Only carbon. Okay, it will be black in color. If you, actually white in color. Sucrose is a white in color. If you add sulfuric acid, what happened? It will be black in color because it absorbs all the water molecule. Now it will be what? Only 12C, correct or not? Plus H2O, okay, 11H2O. Because of what it is doing, it's dehydrating. It removes water molecule from sucrose, correct or not? Then it's called what? Dehydrating agent. Dehydrating, removal of water. Understood? This one property. Another one is very important property. Another one, H2SO4 is an oxidizing agent. Very good. Oxidizing agent. That's also not on. So here one examples, it's very good oxidizing agent. See, it oxidizes carbon to what? Carbon dioxide. Correct? Then as usual NO2 plus H2O. Are you following? It oxidizes carbon to carbon dioxide. That's oxygen is added, no. That's why we are saying it's called oxidizing agent. Understood? These two properties go through, very important. Okay. Understood? That's all. These are about 16th group. That's all. 1 hour first group, half an hour second group, again 15 minutes, 17th group, again 5 to 10 minutes, 18th group. Okay? Okay. Don't worry. These are all important things. You just go through all this, okay? But I didn't do one more thing. Oxo acids. Here we have oxo acids there, no? Oxo acids of phosphorus we studied, no? Likewise here, oxo acids of what? Sulfur. Correct? So oxo acid means, what are they means? H2SO3, H2SO4, H4P. H4, H2O7, sorry, H2S2O7, H2S2O8, these are all oxo acids of sulfur. Just note down. This is one nickname for that, corrosive acid. Okay, that's all. Understood? Right. Next one, 17th group. Finished? Understood? Right. Only one thing, suppose here in our problem solving session also I give this question. How to find out oxidation state of sulfur. So yeah, oxidation state means you just remember hydrogen always +1. Okay, oxygen always -2. Keep in mind. Very, very, very important. At least you must know these elements oxidation state. Okay. Tell me, 1 hydrogen +1, no? 2 hydrogen +2. Sulfur only we are going to find out X. Oxygen is what? -2. So 3 into -2 minus 6 is equal to 0. X is equal to cut off +4. Cut only. Cut only. Sure. Understood. Right. Next one. Finished? Next, 17th group. Okay. What are the elements of 17th group? 17th group, tell me. Fluorine, chlorine, bromine, iodine, astatine. This is only what? Radioactive element. Okay. all are diatomic, What is general electron configuration? NH2 NP 5, correct or not? Okay. This otherwise is called what? Halogen. This is all, simple one. Okay. This yellow, it's greenish yellow. This is all, I think red or brown we can say, no problem. It's called what? Violet. Okay. This two is called what? Gases, correct or not? This one is called liquid. This is what? Solid. Okay. What is the special properties means? Now, when you go down the group, atomic size increases, but this is what? Fluorine is a highly electronegative element. Chlorine is a highly high electron affinity when compared to that. Okay. Then these are all we can say what is the important properties means? Very good. Oxidizing agent, correct? Because all are having what? All the elements need how many electron to become octet? 1 electron. So all are accepting electron, readily accept electron. So that very good. Oxidizing agent, correct? Oxidizing agent it need 1 electron to become octet. So all are readily accept electrons called oxidizing agent. All are strong oxidizing agent. Among this, who is more? F2, correct? Okay, this one. Okay, this information just go through. Okay, here compounds. What are the compounds means? Only chlorine, HCl and interhalogen compounds. 3 compounds are there. Okay, right. See, simple. What are the compounds means here? What are the compounds here? We are going to study about chlorine. This only somewhat heavy. This is HCl. Then here what? Interhalogen compounds. Interhalogen compound. Okay. Chlorine preparations. Decans process. Just keep in mind. I told you many process. Chlorine is prepared by Decans process. You pass. We need chlorine, no? So H2 will be formed. Okay, Decans process. Are you following? Simple one. A process name at least study. Okay, when you pass oxygen into HCl, we get chlorine as well as H2. This is one method. Then electrolysis of brine solution. No, what is brine solution? Brine means concentrated salt solution. Nothing but sodium chloride. Yeah, if you take seawater, is a very concentrated, highly concentrated salt. Brine solution means sodium chloride solution. If it undergo electrolysis, we are getting what? If it undergo electrolysis, we are getting sodium and chlorine. Cl2. So if we add some water molecule, aqueous sodium chloride means we are getting NaOH also. So this one method, okay. Or we can get from lab method K-4 plus HCl we get KCl plus MnCl2 plus, our aim is to get what? Only plus H2O, no? Chlorine, that's all. These are the method. Correct? Decans process. Understood? Then its process, say it's some properties. What are the important properties means? Just note down. Cl2 is a very good bleaching agent. Bleaching agent. It removes, stains from cloth, no? Bleaching agent. It removes color. It removes coloring substance. It removes coloring. We are saying it's called bleaching agent. Okay. Then it's a very good oxidizing agent. Second point, right? It's an oxidizing agent. It's an oxidizing agent. Okay, second point, I'm saying Cl2 is a oxidizing agent. Oxidizing agent means what? Give an example. It oxidizes ferrous sulfate to ferric sulfate in presence of any acid medium. Correct or not? Fe2SO4 thrice. Understood? It oxidizes. Then HCl will be formed. It oxidizes ferrous sulfate to ferric sulfate. Correct or not? Ferrous to ferric. Correct. Fe2 plus is Fe3 plus. Oxygen number increases. That's why it's called oxidizing agent. This is one property. Bleaching agent, oxidizing agent. Okay. Then apart from that, we have one important one thing, that is that it reacts with sodium hydroxide as well as Cl2, again sodium hydroxide as well as Cl2. That is here, if it is cold and dilute, we get one product. Hot and concentrated, we have another product. Same reaction, some concentration will be different. Okay, product will be also different. Sodium hypochlorite, sodium chloride, that's the difference. But this also same. Okay, understood. Just go through. Sometimes, complete the following they'll ask. Importantly, I'm giving most important. This one properties, okay. Then fourth one. That is, it reacts with ammonia. Okay, here also two conditions are there. Ammonia, it reacts with, ammonia. Suppose this is ammonia is excess, we have one product. Chlorine is excess means we get another product. Suppose chlorine is excess. Okay. Now, remember what we do. Ammonium chloride is a product here. Plus I think N2 will be formed, nitrogen gas. Here I think nitrogen trichloride will be formed. Here HCl will be obtained. Okay, right. Go through. Okay. Then that's all. These properties just go through. Apart from that, one more thing. What are the poisonous gas produced by this chlorine? Poisonous gas. Okay, write it here. Just note down. Poisonous gas produced by chlorine means here we studied carbonyl chloride, COCl2. Its name is called what? Phosgene, no? Phosgene. Phosgene, okay. trichloronitromethane. Trichloronitromethane is called chloropicrin. Then ether formula, ether formula. What is the formula for ether? ROR, that O, CH2, here CS, instead of, here, instead of hydrogen, I put one halogen. Okay, here also I put one halogen. It looks like ether, no? It looks like ether, but instead of, okay, here you have halogen. These are all poisonous compounds, they are saying. Okay, tear gases. This is called tear gases. Okay, right. That's all. Go through. Okay. Just few minutes I'll complete. Just note down. Nita? Right. Just go through this. Very standard question. Just memorize as it is. Phosgene, chloropicrin, tear gases. All is made up of chlorine. Now, these are all poisonous gas. Okay. Right. Okay, right. Next one. About HCl. HCl. Now we're going to study about HCl. Only one method of preparation, that is called, name of the process called Glauber process. Glauber's process, just right. Simple. You take sodium chloride, you take sulfuric acid. Simple. NF, H from here, Cl from here. H from here, Cl from here, what? SLB form. Remaining NaHSO4, that's all. NaHSO4, okay. Then properties. Important properties called, it forms, aqua regia. What is aqua regia means? It's a mixture of con HCl and concentrated nitric acid in the ratio 3:1. It's a royal water. Do you know that? It's called royal water. Okay. This mixture is going to dissolve what? Any metal, not especially, gold. Okay. Dissolve gold, platinum, okay, like that. It goes on. Okay. What is aqua regia? Very important. Go through. 3:1 ratio important. Okay, Nishna? Right. Next one. Next, aqua regia is this. Con HCl and con HNO3, just right. Here also oxo acids. Okay. What are oxo acids means? Oxo acids of, chlorine, HOCl, HOClO, just note on, just go through. HOClO3, go. Here I told oxide means compulsory what? Compulsory OH will be there. OH compulsory will be there. Remaining chlorine is what? 17, no. 2, 8, 7. So one bond is attached, no. Remaining 3 lone pair. Cut or not? 3 lone pair. Here, like you try yourself. Here, how many OH group? Here also one OH group. But in this place, oxygen will come. Okay. Then 2 lone pair. Cut or not? It goes on. Okay. Okay, right? That's all. These are all oxo acids of halogens. Okay. Next one, interhalogen compounds. That one's important only, I'll say. Interhalogen compound, very important this one. Interhalogen compound. The symbol is XX dash, remember. Halogen thana, X thana, always you are using X, no. Both are halogen. This also halogen, this also halogen. So halogen compounds are formed by halogens only. Two halogens are combined together, we get interhalogen compounds. Understood? Right. Simple one. What are halogens? Fluorine, chlorine, bromine, iodine. These are halogens. Understood? Right. See, what types means XX dash type, XX dash 3 type, XX dash 5 type, XX dash 7 type. See here, example, ClF, ClF3, IF5, IF7. Both are halogen. Which halogen which write first means, see, listen carefully. But when you have two, suppose here, when you have two halogens, which halogen first write means less electronegativity write first. Less electronegative write first. Kata? Who is less electronegativity? Goes on, this is more electronegativity, yeah. So when compared to this and this is what? Less electronegativity. So 2 times. It belongs to this category means ClF. Yeah, right. Shape only and give, just note down. This is called, linear. This is going to, T-shaped. Square, pyramidal. Okay, it's called pentagonal, bipyramidal. It's enough. Understood? Another one important property is X dash is highly reactive than X2. What's the meaning for this? Interhalogen compounds are highly reactive than halogen. Are you following? Yeah. ClF na interhalogen compound. It's called what? It's called what? Are you following? It's called interhalogen compound. It's called halogen. Understood? Why this highly reactive means the bond dissociation energy is very, very weak. We can use to break the bond, then only it is highly reactive. Due to what? Due to less bond dissociation energy. Okay. Hydrolysis. When you do hydrolysis, any interhalogen compounds, say I am taking one interhalogen compound, that is, ClF. Hydrolysis, we are doing hydrolysis. When you do hydrolysis, smaller can form halide. Smaller means who is halide? Smaller. This is smaller, no? Smaller can form halide. Larger can form hypohalide. That's not all. So it's some important properties. Okay. That's all about 17th group. Okay, right. These are all just go through, very important. It's not okay. The structure they will give as it is. This is a 1 mark answer. Directly they will give. Not only one question. Yeah, 9th standard, 10th standard you studied. The shape of ClF3 is dash. This is only one, but in one question we have 3 questions will be there, 3 or 4 questions. You have to match them. That kind of questions we are getting in P block elements. Understood? Next. Okay. Next one, the few last group, very simple. What are the elements, you know? What are the elements in 17th, 18th group? Helium, neon, argon, krypton, xenon, radon. This is what? Radioactive element. Okay. Noble gases, rare gases, inert gases, so many names are there. Okay. Okay, you know that. No one can form compound. Only who will can form? The xenon only can form compounds. Xenon only can form compounds. What are the compounds it forms means? Xenon forms xenon difluoride, xenon form xenon tetrafluoride, xenon form xenon hexafluoride. Then it is very precious compound, noble compounds. Okay. No one can form compound. The xenon only can form compounds. Okay. These compounds are less reactive, more reactive. All are less reactive, more reactive. Less reactive, isn't it? Because all the completely filled configuration, completely filled. Orbital, what is the configuration? NS2, NP6. No electrons are free, isn't it? Completely filled orbital. Completely filled orbital. So that, okay. So it is not participating in bond formation, less reactive, okay, low melting point, all due to this one. Just note down. Less reactive reason, same reason. Low boiling point, sometimes they are using no weak van der Waals forces, okay. Low boiling point due to weak van der Waals forces, just note down, van der Waals force. Okay, right. That's all. Then these compounds are hydrolyzing what we get. That also important. Understood? I written all this. Right. One more properties I will say. Just 2 minutes. The properties. Hydrolysis properties important. Hydrolysis. Suppose this compound is hydrolysis, what happened? This compound is hydrolysis, what happens? Okay. This compound is hydrolysis, what happens? Okay. First here. O2 will form. But here tetrafluorides, the same compound will be obtained plus one more thing, somewhat different one, xenon oxychloride. Okay, just memorize. Inorganic compound we cannot say. You have to memorize all this. Really, it will be easy. Most important one is its shape and all only they ask in this. You don't worry about the properties and all. Okay, shape. This only just copy them. I'll give the shape. Right. One more thing, last one. I'll give only a few structure. Just note down. That's only very important. Okay. That is, So they'll give. Listen. Easy one. They'll give this one. What's the shape of this? Shape means, you know, xenon, valence electron is what? All are having 8, no? All the elements having 8 electron except helium. 8 valence electron. So outright oxygen whenever bond with what? Whenever oxygen coming, double bond. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Among out of 8, 6 electron bond form remaining 2 electron. Nothing but 1 lone pair. Correct? Sure. All are then tetrahedral. Here also atom is there tetrahedral, but it's not tetrahedral. It's called what? Pyramidal. What is the hybridization? sp3. 1, 2, 3, 4. 3 bond, which is considered as a bond pair. 3 bond pair, 1 lone pair. Okay. Next one. Tell me. This is xenon. Kata. 1, 2, 3, 4. Kata. Fe. Kata. Then 4 only used, no? Valence electron. 4 only remaining 2 lone pair. Okay. So here also atom is present is octahedral. Here no atoms. It's called what? Square planar. Are you following? Understood? But lone, everything we should consider. sp3 D2. Hybridization fully considered. Okay. So right. One more thing I'll give. Xenon F6. Tell me. Xenon F6. Xenon 1, 2, 3, 4, 5, 6. Kata. 1, 2, 3, 4, 5, 6. Here. Kata. 2 electron. I put it here. Okay, this only is present means this is not lone pair means octahedral, but that's why it's called distorted octahedral. Some deviation. Distorted octahedral. Are you following? Okay. sp3 D3. You check whether it is correct or not. Check. Okay. Ask Google. She will tell. Correct. Very good. Right. Okay. Just copy them. Okay. You try yourself. This one. OF4. Okay. Just you try yourself. This is very, very important. You try yourself. You do. Okay. You do like this. Write like this. Okay. Very, very important. This two. Okay. Understood? Up to this. That's all about P block elements. Okay. So I given most important, mostly covered I think. Okay. So any other properties, if I left means you anyhow just go through your textbook also, uses and all, you just go through your textbook. Okay. Right. So you just 4:30 I'll come. 40 minutes, just wait. Okay. Just be relaxed. Okay. Then within 40 minutes, I complete another one small lessons I'll complete. Okay. You just relax for 40 minutes. Then I'll engage for 40 minutes after that. Okay. Right. Thank you, students.